Howdy folks! Today I'm going to do a video about a project that I've been working on for about 4 years now. This is a reproduction of a Hughes & Phillips conversion musket. So before I get started, I got a couple apologies to make in advance. Number one, this is going to be a long video, but the project took me about 4 years to complete, so it's going to take a while to talk about. The second issue is I didn't take any video while I was doing the work. I took a bunch of photographs, so that's all I've got is photos to work from. I generally don't like videos where you go to play a video and it turns out it's just a slideshow of photographs. But that's all I have to work with is photographs. Also, I felt like a video was the best format here because you really need some narration to go along with these photographs so you can understand what was going on. So, that out of the way, let's talk a little bit first about the history of the Hughes & Phillips conversion muskets and why they're special and why I chose to make a reproduction of one. So, at the start of the American Civil War, neither side was really prepared. And so there was a shortage of arms, and as a result, they went and raided the federal arsenals, and lo and behold, they found a whole bunch of obsolete muskets in their inventories. And this included 1816, 1822, 1835, and 1840 flintlock smoothbore muskets. Now, some of these had been converted to percussion through what was called a cone and barrel conversion, where they plugged the touch hole from the old percussion or the flintlock system, and they would drill and tap right into the roof of the barrel and install a percussion cone right there in the barrel. Now, it was known even when they were doing these conversions that was a somewhat iffy conversion because you couldn't count on the thickness of the material that might be there, and you might not get a whole lot of threads in your tap, and so there's some risk that percussion cone could get launched out of the barrel when you fire it. So at the start of the war, there was a big rush to take these obsolete muskets and distribute them to various contractors who would then go about the business of converting them from flintlock to percussion, if that was necessary, or upgrading the cone, to a bolster type system. And in addition, they were to be rifled and have a rear sight installed on them. So that was what the plan was. It was known, even in the 1860s, but it was known that the expanding ball technology was the way of the future for armies. Yes, there were definitely examples of troops that preferred the smoothbore all the way through the Civil War, but as a going affair for the manufacture of muskets, they were going to be rifled. So that was the plan. So in comes the firm of Hughes & Phillips. So Hughes & Phillips got a contract to convert some 12,000 of these smoothbore muskets to percussion and to rifle them. So as part of that process, they basically either cut off the end of the barrel to either replace the cone and barrel conversion or just to do away with the flintlock touch hole and replace that with a new breech that would contain the cone right there. But what they were supposed to do as part of their work was to rifle these guns. And in preparation for that, they added a rear sight. But the guns were needed so quickly that they had performed the conversion to percussion and they had added the rear sight, but the guns were needed so quickly that they were sent out the door without ever rifling them, which makes them somewhat of an unusual example of American-produced smoothbore muskets in that they have a rear sight. So that's unusual. So who cares, right? So why would you want a smoothbore musket with a rear sight? Well, modernly, a lot of people like to shoot smoothbore muskets in competition in organizations like the North-South Skirmish Association. And in this kind of competition, our target loads are so well developed for these guns that it's not difficult to achieve hole-in-hole accuracy at 25 yards off a bench with our precision ammo and our tuned loads. Even at 50 yards, they're capable of very good accuracy. So having a rear sight in that kind of situation is extremely helpful. It makes it so that you don't have to guesstimate elevation anymore. With a normal model 1842 smoothbore musket that only has a bead up here, or for that matter any of the previous generations of musket that hadn't been converted and rifled, all you had was a front sight. That's it. And so, you know, basically these guns were not designed to be shot outside of about 100 yards, and so a front bead was plenty good enough for a soldier to be able to aim and hit a target at that range. But having a rear sight with our precision target loads makes them very highly sought after. And in the North-South Skirmish Association, you can't just add a rear sight to any smoothbore and call it good. It has to be a historically accurate representative model of a smoothbore musket that had a rear sight. So your only option till today has been an original. And the problem with that is, of course, there was only 12,000 of them made. So there's a limited supply of them still available. And of course, the other issue is condition, right? So if you want to find a shootable H&P musket, you know, it's going to start at around $1,500. But it's going to look like you know, a 175-year-old gun. It is not going to look like a pristine example that's just been converted out of the arsenal. And if that's what you want to buy, you know, you're probably going to get off, you know, thousands of dollars for a unissued or very fine example of a Hughes and Phillips musket. And of course, then comes the question: would you want to shoot, you know, such a fine example of Hughes and Phillips conversion? You know, I don't have any problem with people that shoot original guns. You know, a lot of people shoot original guns. They were made to shoot. And of course, you know, all of the good ones are already in private or public collections anyway, so most of the ones that are out and about being shot are, you know, not going to be pristine examples. But it's no doubt that any kind of firearm like this that we shoot in competition, even my reproduction guns, you know, after, you know, 4 or 5 years of shooting them, they definitely start to show the wear and tear of competition use. You know, you get scorched wood, and you get dings and handling marks, and you get the darkening effect of the wood from just the grime of shooting these things. So that is a concern. You know, you are wearing out a gun as you shoot it, especially under the rigors of competition. So that's a concern. So I desired to create a reproduction of this musket. I figured if they were converting these muskets in the Civil War, then surely we can convert reproductions of them today. And once I got that kind of idea in my head, it becomes an engineering challenge to me, and I really just want to see if it can be done, even if it doesn't turn out to be really feasible to do it for whatever reason. But anyway, that was my motivation behind here. I didn't want to have to shell out the money for an original and shoot an original, and I wanted to see if we could make a reproduction. So my first thought was, well, let's do an 1816 conversion, because that's all I knew about. When I first got into this project, I didn't realize that there were, you know, 4 other models before the 42 or 3 other before the model 1842. I just knew about 1816 muskets, and so I went to see if there was a reproduction 1816 that we could use to do a conversion on. Well, it turns out the only manufacturer that makes an 1816 as an actual firearm today is Pedersoli, and they have an 1816 flintlock, and they have an 1816 Colt conversion, which has a drum on the side of the barrel with a percussion cone on it. And neither one of those were really ideal. The lock plate wouldn't be right on the Colt conversion, and it would be a shame to convert a Pedersoli flintlock because you're paying for all the flintlock bits and pieces on the lock that you'd just be throwing away. But that was my thought. Let's do it. If that gun is available, then let's do the conversion just like Hughes and Phillips did. The problem is that Pedersoli's 1816 probably wouldn't pass an SSA inspection muster today. My understanding is that back in the day, when there was a dearth of reproductions, the NSSA was more forgiving on details before they would approve an arm as an approved arm for use in competition. But evidently there's some details with their rendition of the 1816. The stock evidently isn't the correct shape, and maybe there's some other details. I'm not aware of all the problems, but I was given to understand that if I tried to use a Pedersoli 1816 today, that it wouldn't pass NSSA inspection, and so it was useless for the basis of a conversion. So I pretty much had let the project drop. I didn't think it was possible. And then I discovered that in addition to the 1816, there's the 1822, there's an 1835, and there is an 1840 flintlock smoothbore 69 caliber musket. So it turns out that the 1840 was the last U.S. arsenal produced smoothbore flintlock musket. It was followed almost immediately with the model 1842 percussion 69 caliber smoothbore musket. And as you can imagine, being only 2 years apart, the model 1840 is almost identical to the model 1842. And as it turns out, Armisport makes a model 1842. And it's a very nice reproduction, a very close copy of the historical model 1842. And it is also NSSA approved, and dimensionally it's all there. In fact, about the only detail on the model, Armisport model 1842 that wouldn't pass muster today is they cast a steel sight. They cast the front bead as part of the front barrel band. And what it should have is a soldered on brass bead. But other than that detail, the model 1842 by Armisport is a very faithful reproduction of the model 1842. So, aha, says I. If the model 1842 and the model 1840 are almost identical, maybe I can use the model 1842 as the basis to retrovert to look like an 1840 that had been converted to percussion. And so that's what I set out to do. As you can see here, it turns out it's quite possible to do it. So the rest of the video is going to describe the steps that I went through in relative detail about how that happens. I'm just going to give a brief synopsis here of what I did to make it happen. So basically, 90% of the parts on the Armisport 1842 work just as is. The only thing that's needed is work to the stock, work to that front sight post, a new lock, and a breech, a new breech for the barrel. So the stock had to be enlarged in this region back here to account for the pointy lock plate that you find on the model 1840. On the 1842, this is rounded, and so it doesn't extend as far backwards toward the wrist as on the 1842. So in order to make that work, I had to strip the stock and then splice some walnut here behind the cutout for the lock, the mortise, and the same thing on the other side, just because the gun was made symmetrical and it should be that way. So that was the modification to the stock. To make the lock, I had to come up with a model 1840 lock plate. Well, it turns out there's a company called the Rifle Shop, and they make a casting, a raw casting off of an original of a model 1840 lock plate. Well, when Hughes and Phillips converted these from model 1840s, they used 1842 hammers. Well, I already had the hammer from the Armisport model 1842. And it turns out that all of the model 1842 lock internals you can drill and tap, and they will fit right in the 1840 lock. So you'll have essentially 1842 lock internals in an 1840 lock. Now that's not historically correct. The 1840 lock internals were quite different than the 1842 internals, but the NSSA doesn't care what goes on behind the lock plate. So that was my goal. I wanted to reuse all of the lock internals from the Armisport 1842 as a cost savings, and to get a functional lock without having to go find 1840 lock internals. So that worked fine. That was one of the easier parts of the project, actually, was aside from me breaking off taps and generally making mistakes, converting this or using the rifle shop lock plate and converting the parts over. I did it with a drill press and hand taps, so that can definitely be done. That was not a significant problem in the project. Before I get to what was the significant project, obviously I've already talked about I had to replace the front bead here, and that was easy. You just grind off the old one and took a bit of brass stock and soldered on a new one and filed it to the correct shape. Done. The real meat and potatoes of this project is the breech here, the breech of this gun. And the way these conversions were done historically is, as I already alluded to, they took the barrel from the flintlock musket and they cut off the breech end of the barrel. Same thing if it was a Conan barrel conversion. They just chopped it off. And then they created a new breech that threaded into the barrel. So they put female threads on the barrel and male threads on their breech, and they threaded them together, and then you have a new barrel assembly. Well, there's one problem with the Hughes and Phillips breech system, and that was because of the way they threaded the part, they had to reduce the diameter of the bore in the breech because there wasn't enough material the way they threaded it, with that being male, so they had to reduce the diameter in the breech. And what that means is you end up with what's called a patent or patent breech situation, where it's 69 caliber till you get to the breech, and then there's a reduced diameter in the breech area back to the touch hole. That makes it tricky to clean because you can't just run a patch down the entire way like you could with a standard 69 caliber musket. So that was a problem with those kind of muskets. Well, enter the modern reproduction of the 1842. In fact, most reproduction muskets today have a separate cast and machined breech that is threaded onto the barrel. And this isn't done for conversion purposes. This is done as a manufacturing expediency. It's easy to make barrels out of round stock, and then it's easier to cast a breech system that you then do secondary machining operations on, and then you thread them together, and it looks like a single homogeneous barrel that has been forged as one piece. Well, because the reproduction is made with a threaded breech already, it makes it very easy for us to remove that breech and create a new H&P style breech that threads onto that barrel. So that is the verbal story of how I've produced this musket, and you can just show some details here. You can see this gun is essentially a model 1842 that's got a new breech and a new lock and a new front sight on it. So that's the story of how I did it, and in the rest of this video we'll go through slides that show the details of the various steps that I had to go through to make it work. So the first part of this project that I had to tackle was to find out whether it was possible to install a Model 1840 lock into the Armisport Model 1842 stock. So I had to create a lock, and I wanted to use all of the internal components, well, external for that matter, all of the lock components of the Model 1842 lock. I wanted to carry those over to the Model 1840 lock plate. That way I would maximize the number of parts that I was reusing from the Armisport musket. And of course, on the original H&P conversions of the Model 1840, they utilized Model 1842 hammers anyway, so the hammer was certainly going to come along, and I wanted to use all of the internal components for cost savings. Of course, my end objective here is to end up with a musket that can be used in NSSA competition, and to do that you have to get an SAC or SAC approval card, Small Arms Committee. Fortunately,
the Small Arms Committee isn't particular on the internal lock details, because the Model 1840 original lock internals are somewhat different than the Model 1842. But that's not a problem for what we're trying to do. So that worked out okay. So obviously the key to making a Model 1840 lock here is to have a lock plate. And I didn't want to use an original for cost reasons. Plus I didn't want to destroy an original. Fortunately, there's a company called the Rifle Shop, and they offer a variety of raw castings based on original parts for a variety of muskets. And as luck would have it, they offer a Model 1840 lock plate. So I ordered a few of those and was able to polish them up nice and bright. And after some amount of trials and tribulations, including broken taps and misdrilling a hole or two, I was able to map all of the holes from the Armisport Model 1842 lock over to the casting of the Model 1840 lock. And I was able to determine the size of the threads in the Armisport lock plate, and I drilled and tapped the same matching holes in the reproduction lock plate. And after doing all that, it turned out that all of the Model 1842 Armisport lock internals and the hammer, they all mapped right over to the casting for the Model 1840 lock plate. And so I ended up with a functional lock without a whole lot of hassle. If I hadn't made some mistakes, if I had double checked a hole location before I drilled it, and if I had not broken off a tap in the part while I was working, this would have actually been one of the easier parts of the project. So now that I had a functional lock, the next step was to figure out how to install it in the Armisport Model 1842 stock. It turns out that the Model 1840 lock has a pointy tail that is a little bit longer than the rounded tail on the Model 1842 lock plate. So that presents a little bit of a trick for installing this. It's a rather simple matter to just cut the mortise a little bit longer to accommodate the pointy tail, but there's not really enough wood in the stock to create the picture frame kind of border that goes around the tail of the lock plate. So this is where the rubber was really hitting the road for me for this project, because this was the point of no return. I was going to now irreversibly modify the gun that I had purchased new for this project. So this is where it really kind of got scary and real for me. I've never really done any musket work or gun building before, so this was a first for me. So the first step here was to strip the stock so that I could prepare it for splicing in some new wood. And to do that, I used a citrus strip that pulled most of the stain out of the stock, and then I wiped it down a few times with acetone, and that ended up getting it pretty bare and ready for the next step. With the stock stripped, then I was ready to proceed with the removal of some wood so that I had a place to splice in some new wood. So to do this, I wanted a very precise removal of wood so that when I glued in my new blocks of wood, that the seam would be as seamless as possible. So I used a router, and I simply bolted a piece of wood to the side of the stock using the existing lock plate holes. So I had a guide of wood on one side and just a piece of sheet metal on the other to act like a giant lock washer, basically, or a lock plate washer. So I then just used a router and a router bit to essentially mill away the tail of the mortise area for the lock. And I did this on both sides of the stock because, of course, it needs to be symmetrical. After I had cut away the wood, I wanted to make sure that I would end up with a really good epoxy bond with the wood I was splicing in. So I drilled some holes, little short pockets, into the stock in the area where I had removed wood, and also into my little blocks that I was going to splice in place. This almost came back to bite me, because as I was shaping and contouring the spliced in blocks of wood, I actually exposed one of these drilled cavities. And fortunately, it was full of epoxy, but even so, you can see it in the finished product. It looks kind of like a filled-in bug hole. But anyway, if I was to do this again, I'd be very careful. I'd make the holes very close to the inside and shallower. You just need something, for a tooth for the epoxy to really bite into. Probably wasn't even necessary at all, but I just wanted to make sure I had a good bond. The next step was to epoxy in place some donor walnut pieces to fill up the place that I had milled away. And that would give me some wood to recontour to the correct model 1840 stock shape that was required. I wish I had used a little bit lighter color of walnut to better match the stock, but the good news is stain covers up a multitude of sins. So to splice the wood in place, I just mixed up some Brownell's Acroglass. I mixed in a little bit of the tint that they give you with it to try to match the wood, and then I just put the pieces of walnut in place. I clamped them very tightly with a C-clamp, and just let the epoxy cure. Once the epoxy had cured, then the next step was to shape the stock back to the required M1840 pointy shape that was needed. So I started off with files, and I very carefully contoured the spliced in wood until I achieved the shape that I was looking for. And once I got close, I switched over to sandpaper and just contoured it in nice and smooth. And then I recut the mortise for the lock. I had already cut it into the original Armisport stock just to make sure that the lock was going to fit before I started all this. So I really just kind of had to cut the spliced in wood until I broke into that cavity and clean it up nice. And then popped in the new lock, and voila, we seem to be partway there. With all the wood modifications done, then all that was left was to stain the stock. Originally, I used a special walnut stain. It wasn't quite dark enough to my liking, so I used some brown leather dye, and I had been told that that tends to lighten up over time. It's not a very good wood stain, and in fact, that is exactly what happened. So it looks nice and dark in these pictures, but you'll see later on with the finished musket, the wood had lightened up considerably. So if I had to do this over again, I'd stick just with wood stain. So at this stage of the project, we've finished the stock, and we've finished the lock, and the two fit together. And now it's time to move on to the most challenging part of the project, and that was coming up with a new breech for the Armisport barrel. So before I get into the discussion of how I did that, it's important to talk a little bit about how Hughes and Phillips did these conversions. So when they went to the federal arsenals and they found all these 1816 through 1840 muskets, a lot of them were still flintlock, and some of them had been converted to percussion already with what was called a cone and barrel conversion, and that's where they kind of upset a bump on the top surface of the barrel, and then they drilled and tapped a hole right in the barrel and put a nipple right there in the barrel, and then they had a special hammer that would reach, kind of over towards the center line of the gun to be able to hit that cone. So the way that these conversions were done is they chopped off the breech end of the barrel. So they either removed the part of the barrel that still had a flintlock touch hole in the side of it, or they removed the part of the barrel that had the cone and barrel conversion done to it. So they chopped off the breech end of the barrel, and then they created a new breech that had a bolster on it, or snail as it's sometimes called. And that bolster was drilled and tapped for a percussion cone, and it had a rounded belly on it that would fit into the notch in the lock plate where the the priming pan used to go. And that way it kind of sealed up what would otherwise be a hole in the side of the gun there. That breech was threaded. It had male threads on the breech part, and it had there was female threads cut into the barrel, and then the two parts could be screwed together. Because the breech was male, it limited the amount of material that was available for continuing the bore in that breech piece, so it has a reduced diameter in it. And this is what's called a patent breech, and so that presents a problem, because when you go to clean the musket, your 69 caliber jag can't go all the way down to the breech face. So you had to have a special cleaning tool to get down into the cavity that's down in the breech itself. So that made cleaning a little bit more of a chore. So the good news is we avoid all that with our reproduction H&P, and the reason why that is so is just about all modern muskets today are manufactured with a separate breech that's threaded onto the barrel. This is just a manufacturing expediency. It's easier to cast and machine a breech separate from a barrel, and then the two are simply threaded together. But the way Armisport made their breech, the breech is female and the barrel is male. And what that enables is you have a continuous 69 caliber bore right to the breech face. And that's great. And so we're going to carry that geometry over with our new breech so that we eliminate that patent breech problem. So because of the way Armisport manufactured this with the threaded on breech, it therefore becomes very easy for us to simulate the H&P conversion by unscrewing the Armisport breech and then creating our own breech that can then be threaded in place. This picture really shows the heart of the problem. So you can see we have the Armisport 1842 breech with its flat-bottomed bolster, and obviously that's not going to, it doesn't look like the H&P bolster, and it doesn't fill the cavity in the lock plate like it needs to. So this is really the heart of the problem. What I needed to do was to create a new breech that was basically dimensionally identical to the Armisport breech, except that it has to have an H&P looking bolster on the side of it. So essentially, I need to reverse engineer the Armisport breech. So to get started with that, the first thing I did was remove the breech from the Armisport barrel. Once I had removed the breech, I was able to start reverse engineering it. I found the easiest way to go about this was to mock up the bolster using modeling clay. And that gave me essentially exactly the breech that I needed. I needed a breech that was dimensionally identical to the existing Armisport breech, which of course it is because I didn't modify it. And then I simply added material using the modeling clay until I got a breech that looked appropriate for the H&P style breech. Now, the bolsters on the H&P breeches, they came in two styles. They have what's called a large snail and a small snail. So I went ahead and made mine look like the large snail because you can always file the part down, the finished part, to become a small snail if that's what you need it to look like. So that was my intent. And once I had created my mock-up with the modeling clay, I used 3D scanning software to create a three-dimensional solid model of that part. And I was able to use those surfaces to create a true parametric model of the breech that I could then use for further downstream operations. Of course, one of the first things I did once I had a digital model of my new breech was to 3D print one, and that allowed me to create a mock-up in the actual musket itself to demonstrate, proof of concept that that this was going to mechanically work. So now that I had a complete, accurate CAD model of the breech that I needed, it was time to start thinking about how to have the breech manufactured. And what I originally wanted to do was simply have the part CNC machined out of a piece of billet steel directly from the CAD data. That's a relatively trivial modern manufacturing technique. Unfortunately, it was very expensive. The machine shops that I shopped around quotes for all wanted, like basically $1,000 to machine a single prototype, and that was more money than I spent on the brand new Armisport musket to start the project, and so that simply wasn't feasible. So I decided to try to do a casting with limited secondary machining operations, and this is how the breeches are made for the modern reproductions. You can tell by looking at the Armisport breech that it's a cast part, and then they do secondary machining operations to create the threaded hole for the nipple, the threaded hole to screw onto the barrel threads, and then the tang screw is drilled. So that was my thought to approach. I would 3D print a plastic master, which then had to be filled with Bondo finishing putty, and then carefully sanded and smoothed and primed, and then shot with gloss coat to give it a nice smooth shiny finish so it would pop out of the mold easily, which was time consuming to make these masters, but also I had to account for shrinkage, because when you create the mold and you pour the molten wax into the mold, as the wax cools it shrinks. And so I had to make my master oversized to account for that shrinkage, which I did for the very first version of it. However, I didn't account for the shrinkage in the steel. Fortunately, I hadn't had parts made yet, but I could tell when I got my finished waxes from the first iteration that they were too small. They needed to be larger still. So I had to make another round of masters and another round of molds, so that I ended up with a finished wax that was large enough not only to account for the shrinkage of the wax, but would be large enough to account for the shrinkage of the steel. Because the way these waxes are used in a lost wax process is they take the wax part and they dip it in a liquid ceramic slurry, and that's allowed to dry, and then it's placed in a kiln and fired, and the wax vaporizes and leaves behind a hard ceramic shell. And then that they can pour the molten steel into, and then they basically pulverize the ceramic, and you're left with the finished raw steel casting. So that was my original approach, and used Boulder River Foundry out in Montana, I think is where they are, and they did a great job. They really helped me figure out what kind of wax to use, where to allow extra wax for the gate for the steel, and it worked out great. Unfortunately, my finished parts were just barely the right diameter of the barrel. There probably wasn't enough material to polish it down to the barrel diameter. So my shrinkage was still not quite right for the main diameter of the breech, and yet the tang was way too long. Well, that wasn't so much of a problem, because you can always, and I did, grind down the tail of the tang. But my first round of castings were just barely good enough. So once I had raw castings in hand, it was time to move on to the secondary machining operations. Now, I'm not a machinist, and the most sophisticated piece of equipment I really have in my little shop is a drill press. Nonetheless, I set out to try to do at least some of the machining, or if not most of it, on my own. I had 3D printed a fixture to correctly orient the casting on my drill press, and by doing that, I was able to drill the tang screw hole, and then I was able to drill the hole for the nipple, and I used a hand tap to tap the hole for the nipple. What I couldn't do was mill the face of the breech down to its correct length, and then drill and tap the barrel hole. So what I ended up doing was going to a machinist friend of mine and imposing on his time on a Saturday, and we'd go over there. And I think for the first batch, for the first one, he just went ahead and faced off the face of the breech, and he drilled the breech out so that I could tap it. And I tried to do that by hand. I assumed that incorrectly that the tap would simply follow the hole that had already been machined for me, but in fact it didn't, and I ended up with a threaded hole that was very slightly out of axis, and when I threaded the breech onto the barrel, you could very clearly see that it was crooked on the barrel. So it was at this point that I figured that really I would have to have at least the breech bore completely professionally machined, and I wasn't really able to impose on my machine shop friend anymore, and at the same time I had come to realize that at least some of the H&P breeches, the bolster stood proud of the face of the lock plate, and my casting that I had created did not do that. Now, some of the bolsters were flush with the lock plate, but I wanted to be able to do either way. And by making the tall version, you can always file it down to be the flush version, but you can't go the other way. So, and also combined with the fact that the castings just barely were the right diameter, I decided I was going to create yet another round of castings, and that was the next plan. But as luck would have it, one day an advertisement came up in my Facebook feed for a CNC machine shop out of China. And I thought, well, what the heck? Let's see how this goes. And I sent them my CAD model and asked for a quote. And lo and behold, they were able to CNC machine and deliver shipped for about $200 a single prototype. And that was a no-brainer, because otherwise I was faced with creating a new master, guesstimating the shrinkage, another time, and then creating a silicon mold and pouring waxes and sending them off to the foundry. And I had to wait, to the right time. I had to wait till winter time to send the waxes, because there's a risk of them melting in the mail otherwise. And then you have to wait for them to work your waxes into their production run schedule. So this was fantastic. I was able to basically get a finished complete part ready to use for $200. And I did alter the CAD model. I added an extra 15 thousandths of material all the way around the main body to give me some meat for filing and polishing to match the barrel. But basically it was a finished complete part, and that made the project right there. So once I had a machined breech, all that was left was to marry it to the barrel. Unfortunately, that's not as easy done as said, because as I spoke to earlier, with the Armisport design, the breech is female threaded and the barrel is male threaded. And what that means is when you drill the touch hole, that is passing through two different parts. You're drilling through the breech, of course, and then you also drill through the male threads of the barrel until you break through into the bore. And the way Armisport does this, of course, is they don't machine until the breech has been already threaded and mounted, firmly onto the barrel. So when they drill the touch hole, they just go right through both parts and they're done. But because we're fitting a new breech to an existing barrel that already has the touch hole drilled through it, it was important that those lined up. Otherwise, you would end up with an extra hole in your barrel, an extra touch hole, and that could build up with coke, fouling, and become a cook-off hazard, and that's just all around bad news. On top of that, you can't just take the breech and thread it on the barrel and count on it bottoming out at perfect alignment, at 12 o'clock with the tang, lined up with the top of the barrel. You just can't count on that because and the barrel has to be that way because the bayonet lug's already on it, at the 6 o'clock position, and there's already a flat machined on the side of the barrel. So this breech has to bottom out at just the right place, about 15 degrees before top dead center, so to speak, so that when you reef on it with a wrench, it comes to rest directly lined up like it needs to. Because you can't count on where the threads start and stop when you get a machined part. So that requires a skilled machinist to remove material from the face of the breech and from the end of the threads on the barrel until when you thread it, it bottoms out at just the right place. And that was definitely beyond my skill to do. I don't have the machinery and I don't have the know-how. So I farmed out that job to Mr. John Bly. And he did a fantastic job of marrying the breech to the barrel. Perfect alignment. The touch hole ended up going, both touch holes lined up exactly. And he also cut the dovetail and installed the correct model 1855 rear sight. So that was the last big challenge of the project, was getting the finished barrel. And all that was owed to Mr. John Bly. So the last part of the project was actually the easiest part of the project, and that was to put a correct brass bead on the front barrel band. The Armisport 42 comes with a cast-in front blade. They just cast it in steel as part of the front barrel band itself. And when this gun first was put on the market, the NSSA approved that. It was a deviation from what's historically correct, but they just overlooked it and allowed it. But this new gun that I'm making, this H&P, would have to pass the Small Arms Committee inspection, and in order to do that, it would require the correct soldered on brass blade. So this was relatively easy. I simply ground off the cast-in steel blade, and then I fashioned a new blade out of a piece of brass stock that I had laying around. I soldered it to the barrel band, and then I just simply filed it down to the correct shape and height. It's got to be 1/8 of an inch tall, and so that's what I did, and that finished the last piece of the puzzle. So with that, all that was left was to assemble the pieces together, and I was left with a finished reproduction H&P smoothbore musket with a rear sight. So as far as I know, this is the only reproduction H&P that has ever been made. Hopefully it won't be the last, but there you have it. That was my process for coming up with this idea and executing it and putting it all together. and I have already proofed this gun. It probably didn't need it. The breech is every bit as strong as the original Armisport breech that came off of it, but just for peace of mind, I had double charged the gun. My normal target load is 70 grains of 3F GoX and a 6.78 round ball that has been roughed up with the files. And so I did a double charge. I put 140 grains of 3F powder and 2 balls on top of that, and we put it in a lead sled and set the thing off using a string, and it survived it just fine. And I have shot the gun since, and it seems like it's going to be very accurate. Clearly, having a front and a rear sight on a smoothbore musket with our competition loads is extremely beneficial to accuracy. There's no doubt in my mind, having only ever shot an M1842 that only has the front bead, there's no doubt in my mind that having a rear sight is extremely beneficial and makes it a lot easier to aim the gun. So I hope you enjoyed my documentation here of this project. I had a lot of requests for folks to describe how I did it, and so there you have it.